I'm going to also erase these because we probably don't need all this information here. I'm doing the 3.2 grams of nickels. Okay, again, as I said, every single problem in question 4 can be answered with cycle 1. This is the only problem that we have done only once, I think, when we first started the concept of the very first class. We did only one problem. We never ever came back to it. We did so many of the rest so many times, but not this one. And I'm not sure if I wrote this on the test or not, but I'm not going to take chances. I'm going to teach you how to do that just one more time. Single element, so cycle 1. And so we got grams, we're going to atoms. Because there's only one atom, there's a difference when it is an element than when it's a compound. Okay? So 3.2 grams, I'm sorry, let me write it further up so some of you can see. So the given information is 3.2 grams, and then 1 goes on the top. If you go to the cycle, this is the only exceptional problem where you have to tweak your mind a little bit at the very end, not at the middle. So we're going from grams to moles. Nickel is what? About 59, right?
Yeah.
So I just rounded to 59 grams, and this is 1 mole. Because again, I keep repeating, it is not. It's easy for me to say, yeah, this is easy stuff, but I know it's not easy. But I get it because I get it. So 1 mole equals 59 grams. I keep going back between those two because that's when you'll be able to go fluently between this. Okay, the next step, moles to molecules. Nothing has changed so far. Everything is the same. Again, if you know what you want to get rid of and where that's going to go, I think that's part of the problem, but it seems like some of you are just trying too hard with something that you're not too sure about. Okay, we got molecules. Now here's where the problem is. Like in the previous case, this is a compound. We know there's 3 atoms. But we're asking a single element. You can't just put 1 there. That's incorrect. Okay? So a molecule of nickel, because this is not a molecule. This is not even a molecule. This is an element. So this is where it gets tricky. Just put a 1, and again put a molecule of. There's 6.022 e to the 23rd atoms. I think the first class, Tony, remember when I asked you, you said, does all elements have the same number of atoms? You said no right away.
Yeah.
All individual elements have the same.
I don't understand why we do.
Twice, right?
Yeah.
That's because this is not a compound. This is an element.
Oh, okay.
That means you literally have that many atoms when you pick up a single piece of nickel. This is already a ton.
Okay.
Multiply that by another ton. It's going to be, that's just countless atoms. That's why people find chemistry difficult, is because when they see nickel as 1 nickel, they think it is some kind of an object like just 1 pen. No. If I pick this piece of nickel, it contains, if I pick 3.2 grams of that object in my hand, inside the nickel that none of us can see, it's got that many atoms. This process is difficult. I don't want to go too much time on this. Just, you can write it down and ask me after class, because I do have to do problem 5. So
I don't understand what the 1 is. Is it
because
just a placeholder
because
like
it's
this
not a
one?
molecule, right? It's not a mole. But we have molecule here. So I guess you can put a molecule if that helps you, just to get rid of it. A molecule of hydrogen contains. That is the reason why I didn't put it here. Okay, so we'll come back to, there is one more problem, but that is exactly similar to everything we've done in the FDA problem. If we have time, I'm going to come back and do that as well. But let's go do a few in problem 5 section. because that is again, I think that's where most of you struggle. So I'm going to rewrite my cycles. I'm going to erase all this. So let me write the first question. So we have, this is a reaction. You cannot use cycle 1, period. You do, you can, if you're like me, you find your way to go around things. But if you're struggling, I wouldn't recommend you go to cycle 1. Just go to a cycle 2 or 3.
That's like that homework assignment we had, right? This one?
Yeah.
Can we go on to the next one? Because.
No, this is all something a lot of people don't understand.
Okay.
Okay, so the question does not say excess. Now, if you all go to your factual information and look at your cycle, I've been very specific in what I write. On cycle 2 in brackets, you see limiting reactor. It is not there for show, it has a purpose. So is cycle 3. In bracket, you see excess. If you come back to this question, do you see the word? So you've got 2 grams of this. I am not solving the problem, I'm just writing it down. You're asked to calculate grams of this. Does anyone see the word excess anywhere in that question?
No.
So which one of the cycles should you use? Cycle 2, right? What's that?
How'd you figure out, why's it two?
Because it doesn't say
Does
excess.
does the question say the word
Why
excess?
is one then?
Because it's a reaction.
Oh, okay.
Use cycle 1 when it is a single compound or element. Is this a single compound?
So when you bracket into that.
Okay.
And do this.
All right. So let's go ahead and write cycle 2. This is easier because if you follow the cycle every single time, you're going to get it right every single time. If you don't follow the cycle, you must have an alternate way of getting around it, which is okay. You don't need to follow me. I'm writing SR, it's stoichiometric ratio, simply because I don't have to write and run out of space here pretty quick. You go to graph. Please follow the cycle. Again, you use molar mass here. I think on the test version, I do put the molar mass here as well. Now, Tony, are you clear which cycle we're using where?
Yes, I understand it
If you read the question for a reaction, if it doesn't say excess, you don't use cycle 3. I can't get any easier than that because the only way I can make it easy for you is actually sat in your seat and took the test for you. All right, so we got to find, so if the question doesn't say excess, it is a limiting of the reactant problem. We're going to do this in 2 spaces because I don't want you to look below the table and get distracted by that. So I am going to close this as well so someone can see it. If the question doesn't say excess, you've got to assume it's limiting reactant because it says on cycle 2. First you've got to do is apply the cycle for each one of the reactants. Let me write it in stepwise. Apply cycle 2 to each reactant. I'm just going to leave it at that and come back and explain what I mean by that. We've already done this, so it's a matter of review. Okay. Now, if you have not still synced with my wavelength, that is one of your fault. Most of the time I'm at fault. Is this equation balanced?
No.
And I told very clearly I am never going to give you a balanced equation.
Mm-hmm.
So there's not a single question on the test that involves any calculation is balanced. I'll tell you the secret now. So then what should you do? When you
Balance.
do problem 5, similar problem, balance the equation. So apply cycle 2 to each reactant, but before that, this step should be even before, you should write balance the chemical equation. That's the first thing you're going to do before you get crazy with your cycle. So balance the chemical equation. that's it on this side. I'm gonna move the problem, work out the actual problem on this side. Just remember those 2 steps and then apply the cycle. You are going to get the problem right every single time. It's taken me a lot of years to make it foolproof, where you learn, but you also get it right every single time. Okay, balance the equation. Let's start with that. It's the first step. N2 plus 3H2 goes to 2NH3.
We already started now. So it's like 3 into, I mean, yeah, 3 into plus 3H2.
No, you got 2N, 2N,
Mhm.
6. Is my balancing right? I hope not, because then I should jump.
Yeah, it is.
I should not teach after tomorrow. If I can't solve this equation, I'm done. I should just go walk up to the chair's
We get
office and
$100
say,
Let's balance.
I should just walk up to the chair and say, just hire somebody for the next month. I am done. All right, as I said, we're going to use cycle 2. Why cycle 2 again? Because the question doesn't say excess. Which means you have to assume one of them is limiting, means one of them is stopping the entire reaction to go all the way. So you're going to apply cycle 2 twice, 1 for each reactant. Let me write it here. Again, apply cycle 2. I don't want to write too big because then I won't be able to solve the problem in one go. Cycle 2 to each reactant. Okay? This is enough because the cycle 2 walks you through what to do. So we're going to start with 2 grams of N2. That's the given information. Okay, and we're going to go to up to moles, stoichiometric ratio, and then we can, let me actually put a star here, and then what that star means, stop at the stop after the stoichiometric ratio step before proceeding. Because that's just a caution step. You could do it if you're like me, you could do it all in one go before proceeding. I'll probably make that change to my test as well, only for this problem. Okay, we got 2 grams, it's given information. Again, this is N2. If you're going to use 14, that's incorrect. That's 28 grams. So first step is grams to moles. So 28 grams over 1 mole. Now here's where, okay, we did the first step on the cycle. The second step is mole ratio. What is this crazy mole ratio? How many of these, we're comparing each reactant to each product. In each time you do a calculation, you're comparing one reactant to the product. You do it the second time, you're comparing the reactant to the product again. If there is no number, you can put a 1, that's what that is. So you have 1 mole of N2, but we are interested in grams of this NH3. So ultimately, whatever we do, we can't have N2 anymore. It's got to be gone. So for every 1 mole of N2, whatever that number here is, that's got to go in front of here. Let me underline it. For every mole of N2, you produce 2 mole of NH3. As this asterisk suggests, stop right here. Don't go all the way yet, because you're just wasting time. Stop after the stoichiometric ratio step before proceeding. Stop. Now go to the next one. Do this one more time for the hydrogen. So given information goes here. 1. So that is not changed. If you notice one thing on every problem you've done a pattern. We haven't changed track as much. So hydrogen is 2. I'm just going to round it. Makes my life easy for a mole of hydrogen. Don't get too fixated on the 0.8 or 0.9. If it is 155.88, just round it to 156.
That's kind of, and I saw you right there before.
Yes.
Just that question. That's where I got confused on the homework, because after you balance it, it would be 6 hydrogen, so you were only doing it for balance.
Okay, I see what you're saying is, you got the next version, you didn't divide it by the common factor. So you probably had 2N2, 6H2, 4N2.
I mean, how it's 3H2 equals 6 hydrogens, correct?
We're going by the molecule, not by, because you've already used the 2 hydrogens to get the 3, so you don't need to go back to 6 again. Do you all see her confusion?
Yeah.
If you all even understood what her confusion is, then that means you're already going to pass the exam. If you even understood what her question was, I mean, if you know the answer to her confusion, that means you already know you're going to do well. No, you don't do 6 again, because you used the 2 hydrogens to actually balance to get that 3 in the first place. The 3 was not there to start with. If the 3 was already there, then that's when you will worry about it. But I am never going to give
You
you.
have 3 actual H2.
Yeah, the
It's not-
3.
Why is it only 2?
Okay, the H2 is a molecule.
Yeah.
There's 3 means you have 3 of those sitting next to each other. No, the question is, she's asking, should I use 6 here? No, because this 2 is already factored in when you balance to get this 3. So you can't double dip it again. You can only do it once. Okay, so for 3 moles of H2, you get 2 moles of H3. Let me stop here myself and step back and ask, does everyone understand what just happened? It's even easier than the moles to atoms to molecules. There's lesser steps here. Can anyone give me the actual values for these? So we have got rid of everything we don't need. What's this number?
Shouldn't it be 7?
2 over 28 is 4 over 28.
7?
It'll be 1 over 7. It'll be roughly about 0.2. 0.2. And 3.5 times 2 is 7. 7 over 6 is roughly about 1 point something. 1.1, 1.2. I'm just doing the math in my mind. This is 3.5 times 2 is 7 divided by 6. 1.2. Again,
See, that's
don't get, if you want to use all the numbers, please do it. I don't care. Okay? I don't want to spend more time on it because that's extremely cosmetic. If you want to use every single number in your calculator, if you see on the test, it doesn't appear here because I want to make that point. On the test, you will be given a box to write your answer. And above that it says, do not worry about significant figures. I give myself a 5% range. If you are within that range, plus or minus your answer, you're going to get it right. If the answer is 150 and you report me 20, that is incorrect. If the answer is 150 and you report me a 152.5, that is rounding error. Like you may have used a 0.8, she may have used rounding. I don't care about that because that takes away the learning. So I did put it in bold font in brackets. Do not worry about significant figures. Hopefully that helps you bring some smile on your face. Now, let's go write the third step and we'll be able to complete the problem. Find out which one of the, I'm writing, this is not how a chemistry professor would write this. You would just go all technical. I am not. Find out which one of the reactant is least in number. Or is least in moles. You can come and take a photograph of my beautiful handwriting if you want, although that is not required.
Into.
As I said, I will probably put the asterisk on the actual test cycle too. Stop after you get to this step. This is the limiting because it is the least. I can write it here, limiting, cause it is smallest of the two. I'm trying to write it in less space so that one problem is contained in one whole work area. Okay, now this is ammonia. Now the reason now you wonder why you would, I can see some of you would struggle here because you won't write all this. You just write 2, 1, 2, 28. You don't even know what you're left with here. This is ammonia. Keep in mind, we're calculating grams of ammonia. That means both of these are ammonia. So we pick this and complete the last part of the problem. Let me, if I write here, will everybody see it? I'll write on this corner. Let me put a box here so that you know that it is part of the problem, but it is a different step. So now this 0.2 moles is your given information. That's again 1. Ammonia is 17 grams. Because we don't want moles, we want grams. 17 grams goes on the top, 1 mole goes on the bottom. That's the end of the problem. That should be about 2.4. Yeah, 2.4 grams.
Where'd you get 17 from?
Ammonia is
Ammonia.
lower mass. Nitrogen is 14, 3 hydrogens each one, so 14 plus 3 is.
What?
I think you gotta go to elementary school. I thought I was the one that has to go to elementary
I
school.
don't understand where 17 came from. Pneumonia. NH3.
Nitrogen is. Cycle, it's already in the cycle.
No, you don't do that. You don't ever.
I understand now. Okay.
It's already in the cycle. You do not have to memorize it.
I'm going back to kindergarten.
Okay, just like how I did for that problem. Since this is the